Thank you for joining us for the SDDC Virtual Symposium. Over the next 2 days, you'll gain insight and technical understanding of the enterprise digital transformation to software-driven IT infrastructure for compute, networking, and storage. Learn from leaders in this digital transformation, including Hewlett-Packard Enterprise, Cumulus, Scality, Doterra, and Mellanox. You'll also hear from Mark Peters, Principal Analyst and Practice Director at Enterprise Strategy Group, as he leads a discussion on the new paradigm of software-driven and data-driven IT architecture, with special keynote guests, Guy Churchward, CEO and Doterra, and Thomas Sable, Sales Leader Storage North America at Hewlett-Packard Enterprise. That's coming up at 1 p.m. Pacific, 4 p.m. Eastern Time later today. You won't want to miss it. Kicking us off right now, I'm pleased to introduce John F. Kim, Director Storage Marketing at Mellanox Technologies. Known, of course, as a leader in enterprise networking equipment, John is here to share insights on how Mellanox partners with software innovators to provide networking solutions in the software-defined data center. He'll be joined later by Chris Cummings, Chief Marketing Officer at Doterra, for a little Q&A. Welcome, John and Chris.
Thank you, Ruby. Hello, everyone. I'm John Kim from Mellanox Networks. I'm here to talk about networking for the software-defined data center with a specific focus on elasticity and advanced telemetry or advanced analytics with that networking. So first, a brief introduction about Mellanox. Mellanox is an end-to-end data center networking company. We specialize in doing NICs, Smart Nics, IPUs, switches, and cables. And we focus on high speed, meaning 25 gigabit and faster. We also add features for data processing and data security on the networking, and that's part of what I'll talk about today for supporting the software-defined data center. Mellanox last year did about $1 billion in revenue. We have more than 2,800 employees around the world, and I think the big news you may have heard about is that in March, NVIDIA announced that they're planning to acquire Mellanox, so that's something that's very exciting that we're looking forward to. So a little bit more about Mellanox. If you haven't heard about us, we are a leader in high-speed network interface cards, or NICs. In the segment, which is 25 gigabit or faster, what I call high-speed Ethernet, Mellanox has a very large market share. So we've done this because we have very innovative products that help support cloud, security, storage, and software-defined functions, including software-defined networking, software-defined storage, and software-defined security. So I said my talk was going to be about networking elasticity and advanced analytics. So first, what is networking elasticity? This is the ability to support any workload, to scale up and scale out, the ability to run on different kinds of hardware, which is a key tenet of software-defined data center, the ability to run different protocols, different applications, and to protect against changing security threats. And also, it's finally the ability to be flexible and make your IT staff look like superheroes. So you want to be very flexible and very powerful in supporting the software-defined data center. But there are these challenges that are facing IT as you go out there and try to build the software-defined data center. Part of these challenges are the move to increasing amounts of cloud deployment and the move of processing out to the edge of the network. So in this process, in these changes, we have, of course, faster servers and faster storage, which need faster networking. We also have the death of Moore's Law. It's been slowing down, and now it looks like it's actually dying, which means you don't get all that free extra processing power every year with the new servers. There is a new need for AI, or artificial intelligence, everywhere, in the storage, the networking, the applications. And there's a move again to software-defined everything, which you'll hear more about later today as part of the software-defined data center. So what we see is that as you have these moves in the cloud, with the security, with virtualization, with software-defined, the CPU alone can no longer handle all the work. It becomes impractical to assume that your x86 CPU on the servers is going to handle all the tasks of the networking, the security, the virtualization, the storage, and still run your applications efficiently. So we need a better solution. It seems like it's impossible to do all this, but fortunately, by putting more intelligence in the networking, by having a more elastic network, you can accomplish all of this and still have efficient IT in the software-defined data center. A little bit more about the challenges around the edge. So first, what does edge mean and why is it a challenge and how is it different from traditional IT? In traditional IT, you have all the processing in the data center. Devices can be out there on the edge. They can collect data, cell phones, tablets, smart kiosks, smart medical equipment, but all that data still has to flow back to the central data center where it's processed. And if any intelligence or actions or insight comes out of that, it has to then be transferred back out to the edge to the users. So this model works, but it has a lot of latency, and it greatly limits what you can do with the data because, again, everything has to come to the central data center and be processed often, not right in real time, but processed later, and then you can act on it sometime in the future. As you move to the edge, you have more devices, more intelligence, faster networking, like 5G, out on the edge, and this enables new applications. But it also means that you have to move more processing out to the edge of the network. What do I mean by edge? This can mean several things. It can mean the devices themselves, so more processing on more powerful smartphones, on tablets, within a kiosk or a smart cash register or a smart refrigerator or smart digital video cameras that are out there doing automatic quality control or recognizing threats. So that processing can happen there. But the edge can also be a telco data center, a closet within a retail store, or a special edge data center that's being built by a cloud giant or by corporate IT to bring processing closer to where the data and the users are. So that's a key part of the edge. But what happens is as you do this, you find out you need more scale-out capabilities. You need more distributed processing, probably distributed storage. And that is part of what's driving people to a greater use of a software-defined data center, or SDDC. Okay? So as we do this, when we do more software-defined, we see that there's some challenges that come up in terms of efficiency and performance and processing power. Why do I say this? It turns out that when you first deploy a server, you have a bare metal server. This is sort of the old model of IT. The application runs on the server. All the CPUs are for those applications, and everything's fine. You can see in this chart that all the CPUs are green. They're available to run the applications. But then we add hypervisors. We add container management. We add software-defined networking, software-defined storage agents or clients, and maybe extra security features, software-defined firewall, virus scanning, filtering. As we do this, more and more of those cores are consumed by these important but utility or secondary applications and tasks, and fewer cores are available to run the application. This means that now your data center is software-defined, it's very flexible. It might not be as efficient as it could be. It could be tied down, things are slowing down, and you have something that's very flexible, very software-defined, and maybe not very fast. So part of the answer is smarter networking in the terms of Smart Nics or IPUs, I'll explain what those are in a minute, or smarter switches that help you recover that CPU power by shifting these tasks, the storage, the virtualization, the security, onto the network, and then leaving more of that CPU available to run the applications. Again, making your software-defined data center more efficient. So the first part of this story of how can I do that, how can I get more efficient software-defined data center, greater elasticity, and better analytics, that part, part one of that answer is deploying a Smart Nic. Okay. So first, what is a Smart Nic and what makes it smart? So a Smart Nic is a NIC that can handle part of the data plane or control plane on the network card, instead of running it in the CPU and in the software stack where it traditionally has been running. So today, most NICs have a little bit of intelligence. They can do basic offloads. Maybe they can do basic overlay networking. But there's a new category of Smart NICs out there, including from Mellanox, which support a lot more. They can actually be programmed. They can offload the data plane and the data movement for SDN, for NFV, for security, for storage, onto the hardware of the NIC, and off of the kernel, off of the regular CPU. So again, this supports SDN, software-defined networking, SDS, software-defined storage, network function virtualization, security, though we can't say SDS again because we already use that for storage. And the key is that this is hardware accelerated, but it's software defined, and it's reconfigurable and programmable, so it can be adjusted to different workloads, different network conditions, or to respond to different security threats. So that's what a Smart NIC does. And what we see is that adapters in the network side have evolved. They've evolved from the basic or foundational NIC, which all the vendors have, and this just does basic networking. It moves the packets, but all the intelligence and processing is still done in software by the CPU. It really doesn't have any programmability. Its only advantage is that everyone makes them and they're very inexpensive. Next, we have Smart NICs. These are like the Mellanox ConnectX-5 or ConnectX-6. They do intelligent data movement and offload that data movement to the hardware on the NIC, but they retain the software programmability or software-defined networking capabilities, where a SDN controller out there on the network or on the server can tell the NIC what the rules are, where packets should go, what the policies are, and then the NIC will then execute those. And that's what the Smart Nic does, freeing up the CPU. And then the next category is what we call an an I/O processing unit, or IPU. This takes things even further by adding some cores, some CPU cores on the NIC, and allowing you to run the control plane or other software on the NIC, in addition to having those hardware offloads I talked about in a regular Smart Nic. So for example, you can now run the control plane for some of your SDN on the NIC. You can run an agent for a next generation firewall. You can run maybe an agent for software-defined storage on the IPU, and thus you're able to offload both the data plane and the control plane for these important tasks onto the card. And that's the difference between an IPU and a regular Smart Nic. And so an example is Mellanox has a product called Bluefield, and more recently our Bluefield 2. And this is something which is a Smart Nic, plus it has ARM cores and DRAM and a PCIe switch and additional security features added in. So this is something which gives that network extra intelligence. You can run, it's not only very flexible because you can run many different applications on it, but it's very good for analytics because you can actually do either data extraction or data filtering on the NIC, or even basic analytics themselves. So one model is do the data extraction and filtering on the NIC and analyze it elsewhere, in your network intelligence or in your network management or IT management software, or you can actually put some of that software on the NIC, on the IPU, and run it there as well. So this enables security everywhere, both virtualization and bare metal servers, and the ability to accelerate and virtualize flash storage. So more about that in just a second. So again, we're offloading the CPU in more ways. A regular Smart Nic offloads the CPU for data plane, and IPU can offload the CPU for data plane and some of the control plane and additional tasks such as security or filtering. So again, more about what is an IPU and what did we do with an IPU to help support the software-defined data center. We took our regular ConnectX NIC, which is very fast and very smart, but it only really runs the data plane. And then it supports these types of features, and it assumes, however, that the SDN control or the software-defined storage controller is elsewhere. It's on the server or some other software running on a controller somewhere on the network. What we did is we then added these ARM cores to it to turn it from a Smart Nic into an IPU, which we call Bluefield. And now this SDN control or security agent or software-defined storage agent can now move onto the NIC and enable additional features and additional offloads off of the CPU, again, leaving more CPU cores to run the software-defined data center and run the key applications. Because basically you buy CPU cores, which are usually the most expensive part of the server, to run applications, not really because you want to run the network overlay or security tasks or packet filtering. And again, in terms of being flexible and elastic, we offer this in different form factors. So there's a standard NIC, there's an OCP NIC for Open Compute Project, and then there are controller cards that can create security appliances, storage appliances, or NFV appliances, where in fact the IPU, or the Super Smart NIC, runs everything in the appliance and then talks to other controllers or other software elsewhere on the network. A big advantage of this is enabling security everywhere and a very flexible kind of security. So the traditional data center model is that you have security just on the perimeter. We call that the Jawbreaker, the M&M model, where it's hard on the outside, but it's soft and vulnerable on the inside. If you only have traditional applications, no cloud, no edge, that may be okay because you hope that the firewall will stop all the threats on the perimeter. And actually, let me talk more about that in the next slide. So what you can do is, with this security model, the traditional security model, the problem is if someone penetrates the firewall, now they can hop from server to server, they can move from application to application and compromise different parts of your data center, different applications, steal your data, encrypt your data, hold it for ransom and so forth. So this traditional security model has some problems, especially when you go to the edge, when you go to the cloud. With hybrid cloud, or with cloud, you're in fact inviting other people, other applications to run in your data center, and that poses potential risks because you're inviting them into your data center and you cannot be 100% sure if they're secure, or if maybe they're secure but they don't follow best practices and they bring in something else that is not secure. So that's the problem with combining traditional security with the cloud. And And this is something that has to be addressed as you expand the software-defined data center. So a better model is what we call the Jawbreaker Model. And this means that you have security everywhere. So this means that I can bring in Smart Nics or IPUs on the servers, and they can do encryption between the servers. They can do packet filtering. They can do pattern matching and look for those threats and find threats and either stop them or report them to your next generation firewall or your intrusion prevention and intrusion detection systems. So by doing that, the security is now moved out of the main kernel, out of the software, and onto this IPU or Smart Nic hardware. And that makes it more secure because if the server gets infected, you can then detect and block that infection and prevent it from spreading to other servers. And actually just going back for a second, and in addition, by doing this with the Smart Nics or the IPUs, you can enable this security everywhere model where you can have IPsec or TLS between many of the servers or all the servers to make sure that security is everywhere in your data center. And this is an increasing requirement we're seeing due to data privacy regulations, the European data protection rules, US government rules and restrictions. So increasingly there's a need to encrypt data both at rest and in transit. And having the right Smart Nics can help you do that by offloading that encryption, again, whether it's data at rest or data in motion, off to the network hardware instead of running it on the CPU. Okay, let me just move forward back to, okay. So another way you can enable security with the new smart networking, this new elastic networking, is with software-defined firewalls or next-generation firewalls. So the new Smart Nics, things like the Bluefield IPU, they can run agents of the firewall or enforce the firewall policies. They can filter all the packets and say, hey, if any traffic comes from this source going to this destination, let's flag it. Let's mirror that traffic to the firewall controller. Or let's just block that traffic if we think it's a DDoS attack or it's infected with some malware. You can also set up rules that control which applications talk to which storage or which servers. So this allows you to, again, enforce these firewall policies using the NIC hardware, which is much more efficient than running it in the software of the kernel, which is sort of the traditional way. In fact, with an IPU like Bluefield, you can run part of the firewall agent on the NIC, so that brings it closer to the server and closer to the data without running it in the server domain itself, which, as I mentioned, introduces potential vulnerabilities to your security model. Okay. Another capability that we've added to this IPU to enable, again, better security in the world of software-defined data center is expression matching or regular expression checking. And this, again, means that your intrusion detection system, your SDN controller, or your next-generation firewall tells the NIC, hey, if you see this kind of traffic, it's a virus. If you see this kind of traffic, it's a hacker. It's a Trojan horse. And then the Smart Nic, the Bluefield Smart Nic, can check the network traffic or even inspect the memory of the server CPU and say, if I found something, it looks suspicious, let's quarantine it, let's block it, or let's report it to the security controller. So this is a capability that's being added to networking to, again, make it smarter, more elastic, more secure, and enable better analytics in terms of security. Because again, this is a model where additional data that previously was not practical to capture or it was too slow to get can be gathered very quickly by the network hardware and sent on to the storage, the security controller, or the firewall, and so forth. The other thing that these Smart Nics can do is they can virtualize flash storage. So there's a feature, for example, on the Mellanox cards called NVMe Snap. It takes network storage and makes it look like a local NVMe SSD. And this is useful because every application, every hypervisor, every operating system knows how to handle an SSD. But they don't all know how to handle network storage like NVMe over Fabrics or Fiber Channel or NFS. So by doing this, this makes it very easy to deploy a composable infrastructure in your software-defined data center. You can take your software-defined storage from, say, Doterra or from Scality, and then you can virtualize it so any server can see it either as regular network storage or as a local storage device. Again, so that's an example. I talked a lot about security, but that's an example of storage virtualization enabled by smart elastic networking. So enough about the Smart Nics and the intelligence in the network adapter. What about in the switches? How can we add more elasticity, intelligence, and analytics out there at the switch? So traditional thinking is that Ethernet switch is a switch is a switch is a switch. You just look at the cost and the number of ports, but actually it turns out there's a big difference in what different kinds of switch hardware can do, and this really affects how you do your network analytics and the flexibility of your network. So for example, the Mellanox Spectrum switches, there's a Spectrum and a Spectrum 2, offer some advantages. So of course there's faster performance and lower latency, and that's important, but we can't really say that's about elasticity or analytics. That's more just about supporting faster flash storage and more virtualization and doing it more intelligently. So there's that. There's less packet loss compared to other popular switches. And there's fairness on the ports, which means that you can choose any combination of network ports and get fair and balanced performance between them, where many of the other switches out there in the market, if you choose the wrong combination of ports, it turns out some ports and some applications will get more performance and more bandwidth than others. In terms of flexibility, these switches are available in different form factors so that you can buy the right size switch and the right kinds of ports for your application. You may have a bunch of servers that need 10 or 25 gig ports, but you may also have storage or uplink switches or really fast servers that need 100 gigabit ports. And a lot of the cloud giants have been moving to deploy more and more of this 25 and 100 gig networking. So a flexible switch, a smart network switch is going to enable different port combinations and the ability to split the ports out so that you can, for example, start with a 100 gig port, split it into 4 25 gig ports, and then later you can convert it to 2 50 gig ports or one 100 gig port and get the flexibility for exactly the speeds and the number of connections that you need, in addition to being able to deploy either these full width or half width switches, depending on what the needs are for that particular rack or for your data center. We also offer the flexibility to run different operating systems. So we support our own system called Onyx, but we also have a very good integration with Cumulus Linux. So with Cumulus Networks, we have a very powerful, flexible operating system. It supports SDN, it supports automation, Linux-based automation and deployment and provisioning, and we can run that on our switches, and we also have joint support with Cumulus so that you get excellent support if you choose to run Cumulus. So we give you that flexibility to choose different network operating systems. There are actually others that are supported as well, to pick the right network operating system for you, but run it on the best available switch hardware. Okay. In terms of flexibility, we see that, again, this is an example where having the right switch design and the right switch form factor can help you deploy a more efficient network. If you're building a hyperconverged cluster, a small storage cluster, you may not need 32 ports or 36 ports. In many cases, the right answer is you want to have 14 or 10 or 14 or 16 ports, and you want 2 switches for high availability because storage is important, and usually you need high availability for that storage. So Mellanox, again, offers that option with these split-out cables or breakout cables, so you can configure different ports for different connections and get maximum flexibility, or as we say, elasticity, for your software-defined storage, networking, security, and as well as virtualization and containers. In terms of storage, I talked about what are the advantages. Why did I say this switch is good for storage? So of course, besides being fast and low latency and having the right form factors and high performance and being able to split out the ports, also these switches are ideal for RoCE, which is a type of RDMA, remote direct memory access on Ethernet. This is something that RoCE gives you better performance and lower latency, especially when using flash storage. And for example, it's supported by Doterra. It's also supported by some other flash solutions out there. And it's supported by a lot of machine learning algorithms as well. So if you're running machine learning, artificial intelligence, software-defined storage products like Doterra, having a switch that's optimized and makes it easy to configure this RDMA using RoCE is a big advantage in terms of flexibility as well as getting better performance. Our switches also support automation and scalability, and I'll talk more about that, and good telemetry, which is very important. More about that in a second. But back to what I said about predictability and fairness. I said the Mellanox switches are really fair, and some other switches are not fair. Okay, what does that mean, and why would you care? So it turns out that if you have a cloud, private cloud, hybrid cloud, public cloud, and you deploy one of these traditional popular switches which turn out to be unfair, and you don't carefully manage exactly which port goes to which server, you could end up where some of your tenants or clients or your applications get really good performance, shown by this green arrow, and some of your tenants get really bad performance, or 1/4 or 1/8 of the performance they're expecting, just because you happen to have chosen the wrong network port on that switch. So this is sort of a little known thing, but it's very real, and it's something that's very important, because fair and balanced is not just something you say on a political news channel. It's something that's very important in a software-defined data center because you want all the applications and servers and storage to get the bandwidth that they're expecting and to be able to balance that performance and that networking bandwidth across the different applications and servers in a predictable way that you can manage, not something that the switch is sort of randomly choosing. So that's very important. Okay, so in terms of supporting cloud, we talked about how the right switch supports storage, it supports, I haven't gotten to the security yet, but supports virtualization. In terms of cloud, you want a switch that's integrated with solutions like, integrated with containers, integrated with Kubernetes, integrated with things like Red Hat, OpenShift. The ability to scale out and scale up in terms of performance, to be able to build a very flexible network. You want the ability to integrate with OpenStack or software-defined networking like NSX, to run open networking systems like Cumulus. These are all things which make the switches better for cloud and the software-defined data center. So it's something that's supported, and if you're looking at switches, thinking of a refresh or a new deployment, you should look very carefully at not just speeds and feeds and cost per port, but also how well can these switches integrate with my storage, with my cloud, with my monitoring and management, and which actually brings me to the next topic, which is telemetry and network availability and analytics. Oh, sorry, there's one, talking more about the cloud. This is about VXLAN scale. It turns out that when you're using a lot of virtual machines or a lot of containers, you tend to have what we call a lot of overlay network endpoints. An overlay network lets you deploy different virtual machines or containers anywhere across your physical network and have them, for example, move and keep the same IP address. Or have virtual networks that span different racks. So I could have one network, but which actually lives across different racks, or even 2 data centers. And that's an overlay network. But overlay networks impose additional overhead on the networking. And so what you want is you want network cards and switches that can offload this and scale out. So with the Mellanox Spectrum switches, to support the cloud, to support the software-defined data center, we have more scalability for this overlay networks like VXLAN tunnels than any other switch. So that's a big advantage for software-defined data center and the cloud. All right, so I talked about intelligence and analytics and also manageability, and I think you'll hear more later about automation and why that's important. So why is it important and how do we support it? How can we help you with that? So first, automation is important because anytime you go to scale, it becomes impossible to manage all the different ports and switches and servers and do it accurately and securely on a manual basis. You have to have automation that will go and roll out the correct configuration to the switches, the right virtual machines or containers to the servers, and enforce the right policies. So this has to be automated and centralized. So you need tools like Mellanox Neo, or you need a network operating system like Cumulus Linux. And these can integrate with your policy, they can roll out your policies, they can integrate with your software-defined storage, support your applications, and automate the provisioning of just the right amount of networking and storage and compute power, for each application, and change it if needed as the workloads change. So Mellanox's contribution to this is first something called Mellanox Neo. This is a management console. It's software that runs, and it helps control the network switches and the adapters, and it will integrate with tools like Cumulus Linux. And it will help you deploy more rapidly and more intelligently software-defined storage like Doterra, like Scality, and other software-defined storage solutions. So what Neo does is Neo lets you manage and very quickly deploy configurations to the switches, monitor what's going on, collect data, and then you can then also share that data with analytics tools. So we talked about how do we do the analytics. So Mellanox doesn't actually create high-level analytics tools for the network, but we integrate with them and we collect the data in a more intelligent way to enable faster, easier analytics of that critical network data. One way we do this is with the Neo tool. Neo will do advanced monitoring. It'll tell you what's going on. It'll automate rapid deployment. But then it will also, as I said, it'll work with both our own operating system and Cumulus Linux. But then what it will do is it'll help you collect interesting data, including telemetry or statistics, and then pass that on to the analytics tools, the more advanced network analytics tools, which can then help you decide exactly what's going on or what needs to be changed or how much networking you need to buy for next quarter. So that's how Neo can simplify your network and improve your analytics and elasticity. Another way which Mellanox supports this is by having superior network telemetry. So what is telemetry, why is it useful, and what's different about how Mellanox does it? So telemetry is collecting the right data from the right parts of the network and being able to get it and use it in a productive way in a timely fashion. So you want to get, this enables faster time to innocence. What does that mean? That means I have a problem. I need to not only know what's causing the problem, I need to know what's not causing the problem. A lot of problems, people think it's the storage, but it's actually the network, or they think it's the network, but it's really a server, or they think it's a server, but it's the hypervisor. So determining what's guilty and what's innocent is very important in troubleshooting and performance optimization. So good telemetry enables faster time to innocence, whether it's the network that's innocent or the server or the storage or whatever. There's also faster time to problem resolution. Good telemetry helps you find out what is the problem, where is it, and what's causing it. And then getting more out of the network. With telemetry, you can find out if your network is underutilized, and maybe you don't need to buy more hardware, or you can add more servers before you buy more network hardware. Or part of your network is overutilized and needs to be expanded or upgraded to a faster speed. Or perhaps part of your network has enough bandwidth, but it's not configured correctly. So all these help you optimize and get more out of your network, which increases efficiency. And in fact, efficiency and elasticity are two of the key motivations to move to a software-defined data center. So as I said, part of what we do is we have a streaming telemetry agent that's in our switches, and Neo collects this data from the switches and to a lesser extent from the NICs as well. And it can pass it on to analytics tools and things like Grafana or Kibana, as well as search tools, log search tools or network search tools, and other streaming tools like Kafka and Telegraph. So this again enables better intelligence by helping collect the right data more quickly from the right places. We also support event-driven telemetry as opposed to just plain streaming telemetry. Again, what's the difference? So streaming telemetry would be, I'm not sure what I'm looking for, so I collect as much data as I can from as many places as I can, and I hope that if I have a problem, I hope I can find the right answer in all that data. Event-driven telemetry is smarter about it. It's a more intelligent way to support analytics and the SDDC. And that means that when a relevant event happens, like I lost a packet, or a connection goes down, or a buffer fills up too much on the switch, at that point, I take a snapshot of the data, perhaps right before and right after the event, and I share that intelligent, more useful, and more relevant data with Neo and then with the analytics tools, so I can very quickly figure out what the problem is. So the reason you can't just use standard in-band telemetry is, let's say I have I have some 100 gig switches, I'm running at 50% utilization, I've got 32 ports, and I'm trying to sample a high percentage of this data. This could be 62 petabytes a day coming out of one part of my network. So if I try to collect actually that's not even all the data, that's maybe 1% of the data for everything that's passing through all day, 62 petabytes, nobody can manage that. You can't, it's really expensive to store, it's impossible to search all of that, so it's not practical. The better answer is collect the most relevant data and maybe filter it or analyze it a little bit on the switch and then pass that relevant data on to the intelligence tools like Kibana or Grafana or the search tools and get the intelligence that way. Okay. So we have a feature called What's Just Happened, WGH, and what it does is it analyzes its event-based telemetry. So when something relevant, good or bad, happens, then it takes a snapshot of the right data and analyzes it a little bit at the switch and then passes it on. So you can collect less data but get more intelligence from it. Okay, so I think this is a good analogy. You have the haystack, traditional streaming telemetry. It's too much data. It's too hard to analyze. By the time you find the answer, hours or days have passed since that event or that problem came up. With What Just Happened, you get just the relevant data at the right time, and you can analyze very quickly what the issue is and figure out how to fix it. So that's a way to introduce better analytics and more flexibility into your network in the software-defined data center. So better telemetry and event-based telemetry with tools like What Just Happened. Okay, so let me go and sort of sum up what I've been talking about on the network. So first, when you build, what Mellanox has done is we built solutions that were designed for the cloud, and they've been tested and developed and proven in hyperscalers and other large cloud service providers. And this intelligence and all that experience and that innovation is now available in the enterprise and in the telcos and in the government agencies as well as they move to the software-defined data center, private cloud, hybrid cloud, multi-cloud, all these capabilities that are developed and proven at the scale of thousands of servers and hundreds of switches and billions and billions of packets of data running every day is available now for software-defined networking, software-defined storage, software-defined security or next-generation firewalls. And it's available as it integrates with products like Doterra, like Scality. It integrates with some of the HPE management tools, and these switches are available, and these adapters are available through HPE as well, in their servers and with the HPE storage. So this is a solution where we have smarter network cards, smarter switches. I didn't get to the cables, but there are even smarter cables and more flexible cables that we have. And this enables you to have a better, faster, more scalable software-defined data center. It's better for supporting machine learning, artificial intelligence, private cloud, security, software-defined storage, big data, things like Spark. And it does this by offloading more of that work from the server, and offloading more work from the administrators into the hardware and into automation tools. That gives you a smarter, more elastic, more flexible network, and that enables you to get higher efficiency, better performance, and better results for your tenants and your end users in your software-defined data center. And actually, in terms of availability, I want to point out that this type of solution, if you're interested in this, is available in a kit. There's a Doterra Kit. It's available from Doterra, HPE, and Mellanox. And it allows you to basically start building your private cloud or hybrid cloud in a software-defined data center. And it's already configured. You know what to buy, how to deploy it. So this is definitely a way of making it easier. And we've worked with HPE and Doterra and other companies like Cumulus and Scality to make it very easy to deploy this and take advantage of the smarter networking both on the NIC and on the switch, and as well as the software-defined capabilities of products like Doterra and the servers and the management tools that are available from HPE. So if you want to find out more about this, visit doterra.com/cloudkit, and you can start taking advantage of this today. So that's the end of my presentation, but I think, if possible, I'd like to talk a little bit with Chris Cummings, Chief Marketing Officer at Doterra, and discuss a little bit, for a few minutes, discuss a little more about the software-defined data center.
Great, thanks a lot, John. Really appreciate it. We started down this path in Vegas in June, right? We started talking about the software-defined data center and how all these vendors are working together to bring the promise to reality. And glad that we were able to go deeper here and understand more about what Mellanox is doing. When you think about this, though, let's take a step back and look at what do we think the actual adoption rates are for right now for Ethernet technologies, for software-defined on the networking side, and where do you expect it going in the future?
Yeah, Chris, that's a great question. So I think a lot of people sort of assume that there is, all the enterprise storage is fiber channel, but actually it turns out that almost every enterprise has already deployed Ethernet storage in some way for some applications, because Ethernet is ubiquitous, it's cost effective, and increasingly it's higher and higher performance. It's even higher performance than fiber channel if you get the new, with anything newer Ethernet, not just from Mellanox, from HPE, from even our competitors, you get this networking which is faster and more efficient, less expensive. So Ethernet has been more popular for iSCSI, for secondary block storage, for file storage, for object storage, for hyperconverged infrastructure, because in fact many of those are areas where fiber channel doesn't work, or it might work but it's not practical. So I think we're going to see more and more of that. All these enterprises have it. A lot of enterprises are going to be deploying more and more Ethernet for storage. For SDN, again, it's probably the adoption rate is a little bit lower. I'm guessing it might be 20 or 30% of enterprises have some sort of SDN, but I think it's growing rapidly, if nothing else, because of VMware. So VMware has, with their NSX tool, has made SDN very easily accessible and available for any as soon as you start deploying virtual machines, ESXi, suddenly there's very compelling and very easy to use software-defined networking. And then, of course, Cisco and Cumulus and other vendors are offering SDN as well.
Right. So you brought up a good point about SDS and Ethernet-based storage being used for secondary workloads. I'm here representing Doterra, of course. We're going after primary workloads. We're going after high performance. So when you think about what our use case is and going after block, what do I need to be concerned about on the network side as it relates to software defined in a scale out and scale across type of deployment?
Yeah, that's an important consideration. So first thing I would say is actually it turns out that if you look at what the large cloud companies and hyperscalers have done, they've deployed their tier 1 or their high-end block storage on Ethernet. Right. Anyway, so and we see that smart enterprises tend to sort of follow the example and say, how can I learn from the hyperscalers and do it? So I predict a lot of these enterprises are going to be deploying solutions like Doterra for their primary, their tier 1 block storage, because if people like Amazon and Microsoft and Google and Oracle are not, you can say lots of good or bad things about them, but they're not dumb. They're doing what's the smart thing, what's efficient, and what performs and what delivers. And in most cases, for their storage, that's Ethernet. So to your question, so it turns out when you do software-defined storage, of course you want to choose the right vendor, someone like Doterra. You want to choose the right server hardware, someone like HPE. And you want to choose the right networking. So with software-defined storage, you can run it, and software-defined networking. You can run it on any hardware, but it doesn't mean you should run it on any hardware.
Right.
You can get, even though it's software-defined, you can get better results or optimal results by choosing proven, reliable, fast, ideally tested and supported hardware solutions, which again could be servers from HPE, it could be switches and NICs from Mellanox. And so that's an important thing. You also want to make sure the network is provisioned and managed in a reasonable way. With Ethernet so flexible that you can have one network with different traffic classes and virtual networking or overlay networks, or you could have multiple physical networks depending on which is the right use case. But either way, you want to make sure that the networking is configured properly for the particular workloads that you're doing.
Right, and I think it's interesting because I think we are hit frequently with the same question, which is, look, if software is the key to this thing, then why should I even care about the hardware that it runs on? What's your response? Because you're in that business providing the Smart Nics, you're providing the switches. Why would I choose you over another? Because nobody watching this today wants to be locked into, I have to use this vendor and this vendor only.
Absolutely. But one of the big advantages of software-defined is you have that choice, and you can avoid the lock-in, as you said. So that's a very compelling reason for people to go with software-defined data center or software-defined storage like Doterra or an open NOS like Cumulus. So again, you have that option. You can run it on any hardware. Cumulus runs on any switch. Doterra can run on any server or any NIC. But it turns out that choosing the right NIC, the right switch, even the right cables can give you a much better experience. The hardware, in software-defined, the hardware is in theory fungible, but choosing the right hardware really does make a difference in terms of latency. If you have a switch that drops some packets, your software will keep going. It'll deliver the data. It'll resend it and get it, but that introduces latency and delay. If you have a switch that gives unfair performance, then Cumulus will run on it and be just fine, but the applications are going to get strange. Different applications will get different performance, and it'll be hard to figure out why, because you don't realize that the buffer architecture of the switch causes unfair and imbalanced performance depending on which ports you chose. On the Smart Nics, again, you can use a regular NIC, but then the CPU has to do more work. If you choose a Smart NIC, the CPU does less work and more CPUs available to run Doterra software, Scality software, or the virtual machines and the actual applications on that server.
This is perfect because I just saw some data from Scott Sinclair and Mark Peters, who's going to be joining us today, on the adoption, what the most important criteria for adopting software-defined storage. And number one is not make it cheap. Number one is actually increase performance, which means you got to be picky about the hardware you're running on, whether it's the server, it's the NIC, it's the switch, because you're not going to get that performance if you're not. So we really want to thank you for your partnership in making this new Cloud Kit a reality, because this is a way for those that haven't started down the path of using Ethernet-based scale out and scale across storage platforms for tier 1 applications. This is the simple way to get going, and that's why we've been working together. So John, thanks so much for sharing all this with us today, and I'm looking forward to learning more.
Chris, my pleasure, and I'm looking forward to hearing more from what else is coming up today for the Software-Defined Data Center Summit you have here. So very excited to be here. Thank you very much, Chris.
Awesome. Thank you.